Okay, so let me record this. One off what? So I think what I wanted to as I was introducing everything today, just know that we still have crap to do, right? We're not going to be free loaf. We're going to be working every minute we have, but it's going to be a review, which is really, really nice. So the goal is right before the AP test, guess what will be the last unit we review?
9.
No, we just did that. We're not going to review that.
1.
No, unit 8, buffers.
Oh, good.
So the very last thing we'll do
Wonderful.
before the AP test, we'll hit buffers one more time leading into that. Also, we're going to be doing old test. So old actual test. We'll do a test as a group of 3. We'll do a test as a group of 2. And then we'll do an old AP test as a group of 1. Which is not a group.
I thought
but
you had no more tests, Miller.
no, I mean not for points, for practice.
Oh, okay.
So we have the FRQs we're going to be working through. Also, have you done your multiple choice on AP Classroom yet?
No.
Don't forget. Don't forget.
I have it written down.
Monday by 11:45 p.m. So, let's talk Unit 1. What's a mole?
What's a mole?
I know.
I love moles.
What's a mole?
The goals are sick.
The mole is the goal, yes. We know that the mole is the number of what? Particles. Oh, we got to leave those on.
Wait, I thought you said put them on.
I said the door.
Oh.
Number of particles in 1 mole of stuff. And this was based off of carbon, right? In carbon, how many grams are there in 1 mole of carbon? 12.011. And we know that there's 6.022 times 10 to the how many? 23rd particles in 1 mole of anything. So we're going back to the basics here. We're going to hit everything really quick. The word mole represents a specific number. Give at least one common example of a word that represents a specific number. Pi. What else? Dozen. Yes, you got it. Okay. What is the formula mass of a substance?
Wait, why don't I remember this?
Isn't that when you add up all the atomic masses and then you can get your...
Adding up all atomic, masses. Adding up all atomic masses times their what? Subscripts. If you guys remember H2O, do you guys remember the mass of water? Do you guys remember? We did that whole bunch. 18.015. 18.015 AMU or grams per mole. All right? It's all kind of the same. Okay, so what's the molar mass of a substance? The mass in 1 mole. It's the mass in 1 mole. Okay, so here we go. Make sure you guys remember how to do this. Get out your periodic table. What's the molar mass of calcium phosphate?
This is my favorite section.
All right. CP Chem. CC, or just chemistry. Sorry, it's chemistry. It's not called CP Chem. I still call it CP Chem because that's what it was used to be called. You will not have the molar mass sheet on the periodic table on the test, but you'll have the periodic table. But also, you'll most likely be given the molar masses, just like Dr. Bonvalet gave you.
We're going to have it, tough to find it every time.
Though, a lot of times they give you the molar mass because they assume that you can do that. First thing you have to figure out is, can you write the formula for calcium phosphate? Good. PO4, 3 minus.
You do get that list, right?
You don't get the list.
Okay, so we just kind of need to know general.
Yeah, but they're going to give you most of the compounds you need.
So PO4.
Things you need to know is OH minus, NO3, 1 minus.
Will your periodic table have the back of those?
No,
Okay.
will not have the back. Solubility, that's not that bad, right? Nitrates are soluble. What's not soluble? Mercury, lead, yeah. Calcium is +2, phosphate is -3. So I have Ca3PO4 parentheses 2, right? What'd you guys get?
310.118.
I've got 310 or what else?
Yeah.
Was that just off the yellow sheet or?
Yeah, just look at the yellow sheet.
Okay, so 310 point what?
0.174.
0.187. All right? And you can put grams, AMU, either one. I like to do grams. Okay. Calculate the molar mass. Well, we just did it, right? It would just be this, right? 310.187 grams per mole. We have 3 different conversions that we know. 1 mole is equal to a molar mass of substance. 1 mole is equal to 22.4 liters. Where? At STP, which is 1 mole,
1 mole.
1 mole, the,
273 Kelvin,
and 1
1 ATM. And 1 mole is this many particles. Flip the page. So we can kind of come up with a little graph here. How does your staple? Is your staple like? Is it weird? Yeah, this is a weird packet to staple. So 1 mole of substance is the same as 22.4, just to put in graphical form, liters of gas at STP. It's also the same as molar mass. This is just putting this into a little chart. Also the same as 6.022 times 10 to the 23rd particles. So, to convert, you have to use what? Stoic. Yes. You have 6.022 particles of a substance. What would the conversion factor be to go from number of particles to number of moles? What would go on the bottom?
If you have the particles in the 6.
Yes, the bottom would have to be your 6.022 times 10 to the 23rd, and your top would have to be 1 mole. You have 18.016 grams of H2O. What would be the conversion factor for that? What would go on the bottom? The mass, 18.016 grams in 1 mole. What would the number of phosphorus atoms in a 2.34 gram of calcium phosphate be? Stoic it. There's one extra step to be careful about on this one. Notice that we're not talking about particles, we're talking about atoms. Eventually, I've got review sheets, which are like 1-page review of every unit that I'll give you guys. So it's like unit 2, boom, all on 1 page. It's pretty cool. What's this next step?
You do how many atoms there are in the actual compound.
6.
And you just say there's 2 moles of 2 atoms.
1 mole of Ca3PO42 has how many atoms of phosphorus? 2 atoms of P. And I know that 1 mole of P would have how many total? 6.02. Yep. Times 10 to the 23rd. Atoms. So when you're doing atoms, you've got to break it off. You've got to multiply by the actual number. So I got 9.09 times 10 to the 21st atoms of P. 9.09 times 10 to the 21st atoms of P. Flip the page. Flip the page. Now we're getting to our percent abundance. Do you guys remember doing that? Someone was mentioning that at one point already today. Remember how we did percent times average atomic mass plus percent times average atomic mass plus percent times average atomic mass? Yes? Okay. Here we go. So calculate the atomic mass of chromium if I've got the naturally... Wait, chromium? Yes. I know. We're back. So I have 1, 2, 3, 4 isotopes. Number on the top is the what? The number on the top of 1. No. What is this 50? No. The mass. And the number on the bottom is the atomic number, right? So these are all different isotopes. Okay. So show my work here. So what do I have to do? This times plus times that plus that times that. Do it. And you have to add those all up together. Also, you have to make those into percents. So you're not going to actually multiply it by 0.434. You're going to multiply that by 0.0434. Move the decimal 2 to the left. You have to put that into decimal. Because 4.3% in the calculator would be 0.04354.
No, it'd be 1.0.
There's not one. You just
You
move the
have to
decimal.
do one.
What are you?
What?
Yeah,
Move
but
the-
if you do 1, it already counts to move the decimal point.
What are you talking
You have to move the decimal 2 to the left.
49.94, and then...
What number are you on?
times it by-
Wait, just do the calculator.
This, you're going to multiply this by 0.04345 is what you multiply it
Then
by.
you're going to have to move the decimal like that.
No.
That is to move it to the decimal.
No, you can times it by 1.
I'm confused.
If he like proves us all wrong.
Yeah, you can times it by 1, sure, because that does nothing to the number. So yes, you're right.
If you times it by that, it's going to be less than what it is.
No, it's not.
Moving the decimal point.
My calculator is because with this calculator, it might be different. Because with my calculator, whenever I times it by that, it's like less.
No, you're just getting the wrong
No.
answer.
So he's not multiplying by the decimal. That's just what that same thing is equal.
4% is
I don't think he knows.
0.04.
Correct.
If I had my calculator, it would be different.
Great.
Wonderful. Thank you.
I believe in you.
Whatever works.
Grady, don't do that on the 18th.
Anybody get it?
Yeah, 51.99.
That's what I had. I had 51.996.
See, I got
Um,
I got the same thing.
Sometimes for AMU, sometimes you'll just see U or grams or whatever. So you can see grams, molar mass, all the same.
Units.
U is just AMU. It's grams. You can see different things. I just want to expose you to anything else you can see. Okay. So the mass spectrum of an element gives masses and relative things. For the data given, create a mass spectrum and determine the average atomic mass of zinc. So I have to graph these, right? So zinc 64. Here 64 is at about 48%. So here is my 48%. Zinc 66 is at 27%. Zinc 67 is at 4%. Zinc 68 is at 18%. And zinc 70 is at like, right? 0.6%. Very, very, very small. Multiply, 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 add up. And then multiply by 1. Don't forget to multiply by 1.
Don't worry to multiply by 1. I think it's.
Yes.
It's different.
It'll guarantee you got the right answer.
Do it right now.
Because usually in here it puts 0 point whatever you
Here,
have.
okay, so do it how you would do it.
So you put a 1.
Grady, it doesn't know that you're doing a
Do
percentage.
it how you would do it and for the next one.
Or are you hitting the percent button?
Just do it for this. Do it for this one.
Oh, how was the disease test?
Oh, yeah, it actually wasn't bad.
Good. Was it like fill in the blank or what was it?
It was multiple choice. It was like an AP classroom test.
Oh,
Nadia was talking yesterday.
There was some
After I got back from
about
university,
submission.
and Nadia was like, Lucy, it's weird.
The West-
Like, we're done with like
What'd you
the
get?
classes. Like, we just had, she was like, tomorrow's my test. And I was like, yeah, I have mine today. It's like,
Oh.
weird. Like, now it's like, we're like, it's still like work or whatever, but it's just like, it's not real content.
yeah.
95?
All right, do we have an answer?
Grady said 95.
95?
For the top one. I just said the top one.
Bro, it was like
Grady,
50.
you have to
You guys,
multiply.
you literally just said just do that one just to show you.
We know it's gonna be,
I swear.
we know it's gonna be in the 60s, right?
95.
No.
That's not it. I only did one of them.
Yeah, the first one's 31.
Yeah.
65.396.
65.396. Do I have a confirmation on that?
I didn't put 48.
Hold on,
You think I times 63 by 48?
I'm distracted by you.
Because that would totally be
Times and
95.
verses.
Whoa, what?
Do I have a confirmation on that?
Hold on, I'm almost there.
Okay.
I got distracted by
You're
Grady.
gonna have to add that on to the math.
No, it was like contact with them. Okay, I'm gonna
Yeah.
get both.
It's just, it's different.
Hang on. Grady,
What'd you get, Audrey?
Grady's adding this number onto the.
Yeah, I got it.
65.396 grams. Also look at zinc on the periodic table. 65.38. Yes.
Grady is trying to say that every time you multiply it, then you have to add that number back
I'm
to
not
the
saying you
original.
have to.
Well, you can't.
You could.
Maybe
Why?
do that.
You don't need to. But you could.
What would that do though?
Make you more work.
Like it's 95.
Yeah, I'm going the extra mile.
Grady,
I'm going the extra mile.
All right. Circle the word to complete the sentence. Remember empirical molecular formulas. Okay. Empirical formulas represent the lowest or highest ratio of atoms in a substance. Lowest. Substances can share the same empirical or molecular formula. It's same empirical formula, but have a different molecular formula. Example. Analysis of a 37.40 grams of an unknown substance. Oh, Chani boy.
I don't remember how to do these.
You don't have to do this.
You don't have to do this on the AP test, but like you need to know how to do an empirical formula, right?
Empirical formula is different than mine.
So I've got 22.8 grams of carbon. This is not a Chani boy. 5 grams of hydrogen and 8 grams of nitrogen. What's the percent composition? An empirical formula of the compound. So I have to take my 22.814 grams of C divided by the total, which is 37.40 grams times 100. And then I've got to do my hydrogen.
Times one.
You know, times 1. Yes, after that. Then I have to do 5.7596 grams of hydrogen divided by the total, 37.40 times 100 times 1. And 8.8638 grams of nitrogen divided by 37.40 grams times 100 times 1. So, percent carbon, anybody get that?
61.
Let's just do, that's good enough, 61%. Okay? What is my percent of hydrogen? What? 15.4%? That's not right.
He didn't multiply by one.
No, that is right.
That's what I
you didn't
got.
multiply by one.
Yeah, I think that's right.
Why are you making me erase? 15.4%.
No, racing.
You got me tripping, Danny.
Wait, it is.
And then it is 15.4. 61 plus 15.4 is 76.4. 100 minus 76.4 is 23.6.
Yeah. I mean, it says.
Does that look good? Percent of N. Does that look right?
One.
Oh,
Times 1.
Multiply everything times one.
Okay. Now, I have 3% that add up to 100%. If I have 3% that add up to 100, I can assume that these are all
the
Used up.
Grams.
Dang.
So 61% becomes 61 grams of carbon times 12.011 grams of carbon. 1 mole of carbon. Oh, hi Reese. When'd you get in here?
Yeah, exactly.
Did not even notice you coming in. That's wild.
First day of making Chem that we had homework.
That is wild.
I'm serious. What is this?
I got 15.4 grams of H times 1.008 grams of H in 1 mole of H. That will give me my moles of H. And 23.6 grams of N times 14.007 grams of N in 1 mole of N. And that will give me my my moles of N. So remember, your percentages, if they add up to 100, change to grams. So, what do you get for moles of carbon? Anybody get it yet? 5.08. 5.08 moles carbon. Hydrogen, 15.3 moles of H. And nitrogen, 1.68 moles of N. I have 3 moles. Now I divide them all by the smallest. Divide by 1.68. Divide by 1.68. Divide by 1.68. So, what does that give you? This one's going to give me 1. What does your carbon give you? 3. And your hydrogen? 9. So my empirical formula is C3H9N. So there's my empirical formula. Cool? Now, it's not on here, but let's say they said that the molecular formula had a molar mass of, hold on, I gotta do some math in my head. 120. Okay? So let's say that the original had a molar mass of 120, right? And it said, what would be the molecular formula? So, what's 3 times 12? 36 plus 9, 45 plus 14, 59. Almost 60, right? So 60 would be multiplied by what to get to 120? 2. So my molecular formula would have been C6, H18, N2. I was 1 gram off. I was close. Okay. Different types of substances are made up of different types of particles. For each following, draw what a particular level diagram would look like for an ionic compound. What am I going to draw for an ionic compound?
Show them share.
Covalent is sharing. You're donating, so arrows.
I'm not doing arrows, I'm showing particles. Metal, nonmetal, which have what type of charge? Which form what type of structure? Remember when I passed around my molecule?
Oh yeah, the one is
Crystal lattice.
Yeah, you
Crystal lattice. Crystal lattice. So this is your positive, right? Negative, positive, negative, negative, positive, negative, right? There's your crystal lattice. It's pretty good. All right. And then a covalent compound, they're all sharing, right? So it's kind of looks something more 3D like that. That's actually kind of a cool drawing. It also looks like the bubble lab that you do in biology. Don't you like put straws together in bio and like, yeah.
Huh?
Wait, what 3D shape is it supposed to be?
This,
I have rough, so I don't know.
this,
Yeah.
I have no idea.
You said it was a cool draw. I thought there was like something.
I mean, we could make it if we wanted to.
A little cube.
oh shoot.
That's like a pyramid.
That's that would be a pyramidal, yes. We're not there yet though. Not there yet.
Pentagonal.
This would be pyramidal. All right, that'd be pyramidal.
Tetrapyramidal.
All right. A single drop of water contains 3.34 times 10 to the 21st atoms of hydrogen. How many atoms of oxygen are in the same sample? What would I do here? Divide by 2. because we know that water is H2O. So if I have this many hydrogen, I know I need half the oxygen. So when you get to a question, something like that, don't overthink it, right? Just think of your ratio of H to O. Divide by 2, and that gave me 1.67 times 10 to the 21st atoms. Okay, flip it. We're crushing this. Okay, next one. Draw a particle diagram for each of the following. Draw at least 3 units of each substance. Number 1 is a diatomic element. How's it going to look? Double, double, double. Right? What about a compound?
3.
All the same unit. Little, big, right? Little, big, or different colors if you wanted to get fancy. A compound and a monatomic element. What's a monatomic element?
1.
Single element. So big, little, big, 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 little, big. However you want to draw it. A diatomic and a monatomic element. So I've got pairs, single, single, pair, pair, single. And then a diatomic element and a compound. So that's going to be, I'm tired of drawing these special. Big, little, big, little, big, little. Look good? List the beakers that contain a pure substance.
Diatomic element?
Beakers number what, or what? Beakers number 1, I agree with. Beaker number 2,
Wait, no. Just 1 and 2.
just 1 and 2.
Yeah.
Because remember, for a pure substance, you can write a formula, right? I could write a formula for this. This could be H2, right?
But you don't know as much.
I could write a formula for this. This could be HCl, right? I cannot write a formula for these because those are all mixtures. So beakers 3, 4, and 5 are mixtures. So the easiest way to identify a pure substances are what 2 things? Elements and compounds. They don't have to be diatomic. It could just be Fe. It could just be cobalt. Anything that you can write a formula for
Digging out.
is a pure substance. What'd you say?
It's like digging out in the depths of my brain.
I know. That's the point.
It's like I don't know. I just like.
That's the point. Yes.
It's like awakening something.
Then would it be?
NaCl in an aqueous solution, that's now a mixture because it's with water. Okay. Electron configurations. So, why don't you guys do it? At least the first one. Or should we do one together? Do you guys remember this? Or can you do it?
Oh, it's like a 1 and 2.
Magnesium would be 1s2, 2s2,
2p6.
2p6,
3s2.
3s2. Noble gas notation for magnesium would be bracket Ne10 and then 3s2.
I love these.
Do the last 3 on your own.
I'm just writing this.
We good? Yes. How many valence electrons does n minus 3 have?
Three? No, none.
What's the highest energy level? Highest energy level is 2. And what is 2 plus 6? 8. Right? Remember, you can determine your valence electrons from these. Determine your valence electrons from those. In the box on the right, draw a diagram of a carbon atom showing the protons, neutrons, electrons in their correct numbers and locations. Now, not the freshman version of this. We know that carbon is 1s2, 2s2, right? And then what? 2p2. So how many protons go in the middle? What?
Did we do this?
Do what?
This.
I don't think we've really done this, but also this isn't going to be the AP test, but like I just want to show you technically what this should look like.
It's the ring thing, right?
6 protons. How many neutrons? 6 neutrons. So first energy level is going to have how many electrons?
2. Yeah.
Oh, this.
2. Second energy level is going to have 1, 2, 3, 4. Right? You can draw a Bohr model. Yes? Okay. Each electron in an atom has the same or different ionization energy. Each electron has the same or different ionization energy. It's different. We know they're different, right? Because it depends how close they are to the nucleus.
Dang, it's coming back.
Guess what we're getting close to? Trends.
Friends.
Match the current term. Electrons in an atom are of 2 types. The inner electrons, also called the core electrons, and the outer electrons, also known as the valence electrons. Core electrons have higher or lower ionization energy? Higher. Flip the page. Here they are. Your trends. Your trends. So, atomic radius, when going left to right, increase or decrease?
Increase. Decrease is what it says.
It's the one weird one. Pulling in.
Oh, yeah.
Same core charge,
Yes.
right?
But it's more density.
Wait, that's wrong.
Oh.
More density.
More
More core.
core charge as I go to the right, but the same shielding, same energy levels / shielding. What about when going top to bottom, atomic radius? Increase. Why? Because on this one I have the same core charge, right? But more shells / shielding. So it's getting larger as I go down. Ionization energy as I go to left to right.
Increase.
It's going to increase. Why? More core charge, right?
Closer to the nucleus.
Pulling electrons in more. So that therefore it's harder to remove an electron. Electronegativity is the same thing as ionization energy, just explained differently. That's the desire for an electron, right? So once again, increase. Why? More core charge. It's the same reason. Pulling in electrons more. Down here, ionization energy as I'm going top to bottom. Decrease. Why? Because I'm adding more shells, right? So it's easier to remove an electron. And then electronegativity, decrease. Okay. Arrange the following elements based on your knowledge of periodic trends. So here we go. I've got Cr, K, Br, Kr. Number 1, increasing atomic radius.
Oh, we're like bordering them?
You're doing it. Cr is number 24.
from increase to decrease every year.
We're doing, on this one, we're doing small to big. On this one, we're doing big to small. And this one, we're doing small to big. So 2 and 3 should be opposites. Danny, what was your smallest on number 1?
CKR or whatever.
Krypton. Next smallest is bromine, and then quinine, and finally potassium. Decreasing ionization energy. This should be the same.
Oh, wait, I thought, yes.
This should be the same. Kr, Br, Cr, K. Because as I'm getting larger, right, it's easier to remove an electron. And then this one should be flipped. So it should be K, Cr, Br, Kr. On the last page, we skipped something major. Look at the side. Put a star by this. Because what did we skip here? We didn't even talk about it. Coulomb's law, right? So remember Coulomb's law is charge 1 times charge 2 divided by R2? Yes? So down here, answer the questions based on these particles. Which one of these is going to be the most attractive? First of all, in order for something to attract, what do the charges need to be?
Negative.
Opposites. So this is going to be either what letters? It's going to be either A or E. Well, which one is it going to be? 3 times 2 is 6. 6 divided by this squared, 6 divided by 9 is 2/3. So this would be 2 over 3. 2 times 1 is 2. 2 divided by 2 squared is 2 divided by 4, which is 0.5. Which one's bigger? E. Most repulsive.
Is it the piece high D? And it's like positive maybe?
So is it
Oh,
D?
C.
I think it's because they're so.
Remember, if it's going to repel, right, they need to be closer together, right? So 1 times 1, 1. 1 divided by 1 is 1. 3 times 4 is 12. 12 divided by 16 is definitely less than 1, right? You can also kind of tell by the picture, but it's going to be C. If the distance between valence electrons and nucleus were doubled, what would happen to the force between the two particles? It would decrease to 1/4. It would decrease to 1/4. Same thing. Same thing. Then we went to photoelectron spectroscopy. What element is this? 1s2, 2s2, 2p6, 3s2. This is half, so that's going to be, or wait. So 3p1, which is going to be aluminum. Going to be aluminum. Remember how to do that? Yes. Given the following electron configuration, construct a photoelectron spectrum down here. First of all, remember, why do these numbers go down on the bottom? What does this represent on my axis? The nucleus. So don't forget, that is your nucleus. So my 1s2, let's put it, I don't know, has to go up to the second line, right? Yes? And then there kind of needs to be like a dash dash, right? There's a big jump. Yes. You don't have to draw that, but then I'm going to have 2s2, which should be about the same height. And then 2p6, which should go all the way up to 6, right? And then I should have a jump, right? Because I lost a whole level of electrons. and then 3s2, and 3p4, which should go like that. What element is that? Sulfur. So, in summary, our trends. We're not going to spend a lot of time on this. Left to right, ionization energy goes up. Top to bottom, it goes down. Electronegativity, left to right, it's the same, right? Up, down. Atomic radius, left to right, is going down. Top to bottom, it's going up. And the other cool thing is, on the bottom of these pages, if there's like something that you don't remember well as we're going through this, go to the AP Daily video on AP Classroom. It's pretty sweet. Flip the page. Oh, we're finishing this right now. Let's go. This is great. Here we go. I have 1 valence electron and 10 core electrons. What is my name?
Na, sodium?
Na. You guys remember doing core electrons?
Yeah.
That was that POGL we did, right? How do you get that? It's the atomic number minus the group number. Yes? Okay. My valence electrons are located in a 3p. I'm the smallest element in this period. What is the name and group number that I am?
Argon?
Argon. In group number? 18. I have the lowest electronegativity and the lowest ionization energy. I'm never found free in nature. That means I'm very, 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 very reactive. Remember Salvagi? Francium. Francium. I'm transitional. I have an ionization energy less than cobalt but more than manganese. What's my name? Iron. We're in group 14. Our AR is less than germanium. What are our names and period numbers? There's 2 elements here.
Wait, what?
Atomic radius.
Less than AR?
Atomic radius is less than germanium.
What's germanium?
GE.
Or carbon.
There, my AR is less, so it has to be smaller.
Yeah, so it has to be carbon.
So it has to be carbon and silicon. And then this last one is something kind of out of the scope of AP Chem, but you guys can try it. I have an oxidation number of -3. I have the lowest ionization energy in my group. What is my name?
Nitrogen.
It's the
Oh, wait.
lowest.
Oh, yeah.
So it is.
So is it?
Or,
Oh, wait, no.
are you including that man-made element?
UV?
What's that?
Are you including the man-made element?
Yes.
What?
So UUV?
Yes. So this would be UUP. Why do members of the same group have similar compounds, similar properties? Because they have the same number of valence electrons. Same number of valence electrons. Using your knowledge of the following elements will bond with a 1-to-1 ratio. Which will go 1-to-1?
Potassium?
Which of the following elements will bond with oxygen in a 1-to-1 ratio? Calcium. Because calcium is the only one that has a charge of 2. Oxygen is a -2, +2. Given the following formula, explain how this formula is derived. Well, we know that strontium has what charge? Chlorine has a -1. That means strontium has how many valence electrons? 2. Chlorine has how many valence electrons? 7, right? So strontium wants to give 1 to chlorine, yes. Which means they need another what? All the way back to freshman year. 1, 2, 3, 4, 5, 6, 7. It donates 2. Because it donates, it's ionic. That's how you get the formula. And that is Unit 1.
Wait, so what is homework?
Homework.